All right, so these notes are on how to find the volume of a 3D figure. You might also have heard them called a solid. When I give you the volume formulas, instead of doing the volume in terms of all the different dimensions, I'm going to give you something a little bit more general because it can apply to a lot of different shapes that are similar. So this section is prisms. These are three-dimensional figures with a pair of parallel bases. So in this particular picture, the bases are both rectangles, but they could be other shapes. So here we have rectangles, but here, if you can picture this like tilted on its side, the bases here are triangles. The bases for this one are hexagons. So we have a three-dimensional figure with a pair of parallel bases, and then the lateral sides, lateral is like sides, the lateral faces are all rectangles. So the volume of a prism is going to be the area of the base multiplied by the height. So in the past, you might have heard length times width times height, and that's because the length times the width is the area of a rectangle, and then you have that multiplied by the height. So we're going to memorize this as area of the base times the height, or you could do capital B for area of the base times height. And the reason we're going to do that is because now we have one formula for all three of these shapes instead of three different formulas for these three shapes. So the first example wants us to classify the figure, and when I say classify the figure, I want you to write the name to describe what type of prism it is. So this one has bases that are rectangles, so I'm going to say this is a rectangular prism. And so the area of the base, I can see that 6 has been labeled down there, so that would be 6 feet. So the area of the base is 6 feet multiplied by 3 feet, and 6 times 3 is 18 feet squared. And so that means that the volume is the area of the base multiplied by the height. And so the volume for this one is 144 feet cubed. Now, some people only multiply numbers when they do this. I was including the units because if you include the units when you make all your multiplications, when you do all your multiplying, if you keep the units in there, then it's easy to keep track of what your final units should be. So feet times feet would be feet squared times feet would be feet cubed, which we know is what matches volume. All right, next for example 2, the classification for the figure would be a triangular prism. And so here, when we do the area of the base, we have to picture this prism like propped up on its side to make it kind of match how this one is resting. So the area of the base is going to be the area of a triangle, and the area of a triangle is 1/2 times the base of the triangle, which would be 4.5 centimeters, times the height of the triangle, which is 5 centimeters. So the area of the base is 11.25 centimeters squared. And so now our volume is going to be that area of the base multiplied by the height of the prism, and this one has a height of 8 centimeters. And so when I multiply all of those out, I get 90 centimeters cubed. All right, this one is going to take a little bit more effort just because it's a hexagon. So since the bases, the top and the bottom base are hexagons, this would be a hexagonal. So when I looked at this, I was trying to remember if there was a formula for the area of a hexagon, and then I realized you could just break it up into triangles. Now this would be a regular hexagon, and what I mean by that is that all of the sides are the same length. We're not going to get super crazy with this because some of the ones with this where you'd get super crazy require you to have learned some stuff in pre-cal that we haven't learned yet. But if I look at this, if that's 13, then this is 13, 13, 13, 13, 13. And what I can do here is I can take this and I can make a triangle from that. So that's one triangle, there's 2, there's 3, there's 4, 5, and 6. There are 6 triangles. So to find the area of the base, I'm going to say I have 6 triangles. And each triangle is 1/2 times the base, which is 13 centimeters, times the height, which if you squint and look really closely, I'm pretty sure it's 11.26 centimeters. Or if that's not it, we'll pretend that we read that correctly, or that I read it correctly. So the base is 439.14 centimeters squared. And so then for the volume, we have to do the base multiplied by the height, which is 29 centimeters. And so that means that the volume is 12,735.06 centimeters cubed. So if I give you something like this, maybe a pentagon or a hexagon, something like that, it would be something that you could maybe look up the formula for it, or maybe something like this where you could break it up into another shape to help you find the area of the base. All right, the next is a pyramid. And so the volume of a pyramid is 1/3 times the area of the base multiplied by the height. So a pyramid is a 3-dimensional figure with one polygonal, whatever, base. So this one happens to be a rectangular base. This one is a triangular base. You could have a trapezoid. You could have all sorts of different bases. The lateral faces, those are all the sides, are triangular, and they meet at an apex above the base. So this right here, let's go ahead and label it. This is the apex. Now sometimes they're giving you this height right here. Sometimes they give you this height right here, which we would call the slant or the lateral height. And remember, these are like lateral sides. And so lateral height is just like the height of the side instead of the height of the actual shape. And if you guys can see it, there's actually a right triangle in there. And so if they ever give us the slant height instead of giving us the height of the pyramid, then we'll have to use the Pythagorean theorem to solve for the missing height. All right, so just keep that in mind. All right, so with this one, we're going to go ahead and classify the figure. This would be a triangular pyramid. And so I'll go ahead and find the area of the base. So I can see that the base is a right triangle. And so I'm going to say my area for the base would be 1/2 times 8 inches times 6 inches. And so the area of the base is 24 inches squared. And then that would mean that the volume is 1/3 times 24 inches squared times the height of 10 inches. So this time they didn't give us the lateral height, they just gave us the height of the whole pyramid. And so the volume ends up being 80 inches cubed. All right, so examples on the back. We have a cylinder, which is a 3-dimensional figure that has 2 parallel circular bases that are connected by a smooth closed surface. So here's our cylinder. And then the volume for this is also just going to be area of the base times the height. Or B times H. Actually, we could fix that on the front too. So pyramid would be 1/3 area of the base times the height. All right, so again, I'm writing it this way so that it would potentially be something you could remember later on, because I found some of these shapes come back up in calculus later, and a lot of my students don't remember how to find those volumes. So that's why we're gonna hopefully write these formulas in a way that we can truly memorize. All right, so I found an example of a cylinder that's like something other than what you typically see. So the classification for this example would be that it's an oblique cylinder. So oblique cylinder is just like a slanty cylinder. Oblique is another word for slant, but I didn't see any pictures where they were called slant cylinders. So we're going to go ahead and use the word oblique. So this is an oblique cylinder. And if you look at the problem, so first we're going to find the area of the base, actually, and then we're going to have to find the height in a second. So the area of the base is a circle, and to find the area of a circle, you can see that they gave us the radius is 4. So the area of the base is going to be pi times 4 meters squared. And so the area of the base, 4 times 4 is 16, so that's 16 pi meters squared. And then to find the height, we have to do a little bit of work. So here's going to be the work we do to find the height. I can see that this is a right triangle, and they gave me the A side and the C side, but they didn't give us the B. I'll go ahead and leave it as A. Actually, I'm going to call it H for height. All right, so Pythagorean theorem says 9 squared plus H squared equals 15 squared. And so 81 plus H squared equals 225. 225 minus 81 is 144. And so the height is 12 meters. So now we can go ahead and find the volume. We have the area of the base, 16 pi meters squared, times the height, which is 12 meters. And so the volume is 192 pi meters cubed. Okay. A cone is a three-dimensional figure that has a circular base and a vertex on the other. Let's go ahead and label the vertex. So in a pyramid, they call it an apex. In a cone, they call it a vertex. And then the vertex and the base are connected by a smooth, closed surface. So we are going to write the volume, which is, again, 1/3 times the area of the base times the height. So you'll notice that there's definitely some similarities in these formulas. The ones that go straight up and down are just area of the base times height. The ones that go in are 1/3 times the area of the base times the height. So that makes it a little bit easier to remember. So here we're going to go ahead and find the area of the base, which again is a circle. So I'm going to say pi times r squared, so times 10 centimeters squared. And so I have 10 times 10 is 100, so I have 100 pi centimeters squared. And then this time they gave you the height. They drew it outside so you could see that it really is like how tall it is from the base to the vertex there. So the volume is going to be the area of the base multiplied by the height. And 16 times 100 is 1600 pi centimeters cubed. So there is our volume. Okay. And last but not least, we have the one that's kind of the oddball. That's a sphere, which is a three-dimensional figure that has no bases and a surface where all the points are the same distance from a central location. So if you start at the center, every single point is like the same distance away from the center. And the volume for this one, we're literally just going to memorize it. It's 4/3 pi r cubed. So I think of it as a three-dimensional circle, but it's a three-dimensional figure that has no bases with all the points equally distant from the center. All right, so here, to give you guys a problem that was more interesting than just a normal sphere problem, I got pictures of basketballs for you. So a size 6 is a woman's basketball, a size 7 is a men's basketball. That's how I think of it. So for both of these, they gave us the circumference. And so if you guys recall, the formula for circumference is 2 pi r. So if we look at the size 7 ball first, I want to find the volume of it. The circumference is 29.5. So I'm going to say 2 pi r equals 29.5. And I need to know what the R value is because that's the only thing I have to plug into the formula. So R equals 29.5 divided by 2 pi. And so now I can say the volume of that particular basketball would be 4/3 pi times 29. I'm sorry, that 9 looks dumb. Let me erase that and fix it. 29.5 over 2 pi, and then this is inches cubed. All right, so I would show you typing it into a calculator, but my calculator's across the room. So I just typed it in like this. When I typed in the 29.5 over 2 pi, I used the fraction function on my calculator. I made sure to put this in parentheses so that it would cube the top and the bottom of the fraction. And what I got is that the volume for a size 7 basketball is 433.526 inches cubed. So then we're going to go ahead and repeat the process for a size 6 basketball. And so we're going to say that the radius, if the radius on this one was 29.5 divided by 2 pi, then this one would be 28.5 over 2 pi. And so the volume here is 4/3 pi times 28.5 over 2 pi inches cubed. And then this volume, oh, that startled me. Sorry, alarm. So this volume is 390.916 inches cubed.